Plays a ball toss game. He stands at the starting point and throws the ball into a basket 4 feet away. The height of the ball is the perpendicular distance from the ground, is a function of the horizontal distance from the starting point. So basically, what that's telling us in that sentence is that this is going to be the height of the ball and then the horizontal distance from the starting point. Okay, so we're going to plot the points and we already labeled the axes. So this would be an ordered pair 2, 0, another ordered pair 3, 3, 4, 4, and so on. So I'm going to plot each of these points. And this is going to be a parabola formed by that piece of paper. Okay, so the initial height is the same as 5 feet from the starting point. Okay, so this right here is going to be our initial height. Okay, so our initial height is 0. So if our initial height is 0, the same as 5 feet away from the starting point. 5 feet away from the starting point is right here. And 5 feet from the starting point, the ball is 3 feet high off the ground. So initial height is 0, 5 feet away from the starting point is 3 feet. So that would be false. Those are not the same. The highest point reached by the ball was 4 feet. So if we look here, this is the highest point, and that is 4 feet. That's as high as the ball is going to go, 4 feet. So that's true. The height of the ball increased from when the ball was at a distance of 2 feet from the starting point to a distance of 4 feet from the starting point. So between 2 and 4 feet from the starting point, is the ball increasing? Yes, it is. So it's increasing from 2 to 4. So that is true. Okay, number 4, moving on. Which of the following graphs represents a vertical stretch? Remember, a vertical stretch is when you have an a value greater than 1. Okay, so right here, the a value stays the same because here my a value is 1, so anything greater than that will be a vertical stretch. And right here, it's also 1, which means it's going to stay the same. It's not a stretch or a shrink. Right here, 7 over 5 is a number greater than 1. That's greater than this a value here. So that would be a vertical stretch. Part C, 5 over 7 is actually going to represent a vertical shrink because that number is less than 1. So we're not going to choose that because, again, looking for the vertical stretch, and can't be D then. Number 5, which is a factor of this trinomial? So we're going to go ahead and factor 2 terms that multiply to give us x squared, or x times x, 2 terms that multiply to give us 18. That will add up to that middle term, positive 3x, is 6 times 3. So multiplying diagonally, x times 6 is 6x, and x times 3 is 3x. So to get positive 3, I'm going to need to subtract these, so I'm going to give them different signs. We keep the sign from the larger number, so the larger number will be positive, and then 3 will be negative, because when we add these together, it gives us positive 3x. So this top, we just carry over the positive, and the second part, carry over the negative. So your factors are x plus 6 and x minus 3. And we see x plus 6, x minus 3 isn't there, but that's okay. So our answer is C. Number 6, what are the solutions for the quadratic equation? So as we go through this, we want to remember that this is looking like it wants to be in standard form. And whenever we have standard form, we're going to look to try to factor first. Okay, so we're going to factor this first, but we need to put it in standard form, which means we need to move this 6 to the other side of the equal sign. To move over that 6, we're going to add 6 to both sides. So we end up with x squared minus 5x plus 6 equals 0. And so now we can factor x times x to get to x squared. And then to get negative 5x, you can try 6 and 1 or 3 and 2. But since this is a positive number, we want to pick 2 negatives to make the positive 6. So 3 and 2 would work and not 6 and 1. So x times 3 is 3x and x times 2 is 2x. To get to negative 5, these both would be negative. So you carry over the negative, and our factors are x minus 3 and x minus 2. Again, you can always double check your factors by multiplying them out. And you would end up with this if you multiplied these. Okay, and again, the negative 3 times negative 2 at the very least would give us the positive 6. Okay, so once you have your factors, you set them equal to 0 and then solve. So x equals 3 is our first solution, and x equals 2 would then be my next solution. So the answer is C. Number 7, we're looking at the graph of the homework grade. What is your homework grade if you completed 20 assignments? So we're going to look here at our x-axis and find the line. For 20 assignments, the homework grade percent is 95. You can look right here. So 20 completed assignments is a 95% homework grade. David is solving the equation by completing the square. So remember, completing the square, we're going to be using b divided by 2 squared somewhere. Okay, what number should be added to both sides of the equation to complete the square? So when we're completing the square, again, we wrote it right here, the number that we add to both sides of the equation to create that square, perfect square trinomial is b divided by 2 squared. Your b is always going to be the number in front of x. So to use my formula, b divided by 2 squared, I get negative 3 squared, which is 9. So what number would I add to both sides? 9. Again, using your formula b divided by 2 squared. Number 9, what are the x-intercepts of the graph? So again, x-intercepts we know means solutions. So we're going to be solving. What we can do again is factor and then set our factors equal to 0. That's always what you want to try first when you're looking for solutions. You try factoring first. And then I had you right over here. We're going to always try factoring first, and then keep in mind if your standard equation is not factorable, then use the quadratic formula. So we're going to keep that in mind. Always try factoring first, and if it doesn't work, not factorable, then we'll use quadratic formula. So back to this one, we're going to try to factor. So we can try 4x times x, and then we want to add up to 12x. So maybe trying 5 and 1 or 1 and 5, but that actually wouldn't work to add up to 12. So I'm going to change this to 2x times 2x. Then 5 times 1. So multiplying diagonally, 2x times 5 is 10x. 2x times 1 is 2x. and these signs would both need to be positive to add up to 12x. So carry over the positive on the top, carry over the positive down here, and my factors are 2x plus 5 and 2x plus 1. This is also the same equation written in intercept form or factored form, so once you get those factors, you set them equal to 0, and we'll have our x-intercepts or our solutions. So subtracting 5, I get 2x is equal to negative 5, then divide by 2, and x is equal to negative 5 over 2. Then minus 1, 2x equals negative 1, and divide by 2, x is equal to negative 1/2. So my answer is D. Number 10, which of the graph represents this equation here? So whenever we have the parentheses squared, this is already in vertex form. So we know our vertex just by looking at this equation. You take out the number in the parentheses, change the sign. So this is positive 3, and then you just copy down the number out here. Positive 3 comma 2 is our vertex. Okay. From here, I originally had you make a table where your vertex would go in the middle of the table. Okay, so you can do it that way, but we can see just by looking at these graphs and do some eliminating. So 3 comma 2, so A looks good so far. C, the vertex is over here at negative 3, 2, so that's not going to be our answer. Over here at B, negative 3 comma 2, also not going to be our answer. And then D is at 3 comma 2 here. Okay, so just by looking at this graph that opens down and this graph that opens up, we can always look at our A value to tell us whether the graph is negative or positive. This is a negative A value, which means my graph will be opening down. So that is how I can already see my answer is A. Number 11, what is the product of these numbers? Product means we're going to multiply them. Okay, so 10 plus 4i times 10 minus 13i. 10 times 10 is 100. 10 times negative 13i is negative 130i. 4i times 10 is 40i. And 4i times negative 13i is going to give us negative 52i squared. Can you guys close the door for me, please? Sorry, you guys. Okay, there's something going on out there. Okay, so when we get to this point, we're going to combine our I terms together. So I'll leave 100 for a second. Negative 130 and 40 is negative 90. So combining those imaginary terms together, negative 90i. And then we need to remember that I squared means negative 1. So I'll write that here. I squared is equal to negative 1. So when we get I squared, we're going to replace it with negative 1. And actually, what happens is this becomes a real number, negative 52 times negative 1, positive 52, and then combine your real numbers, you get 152, and then minus 90i. So we want to make sure that we don't leave our answer like this, like A, because you want to simplify all the way, and we don't ever leave I squared in our answer. And then same thing with C, we don't have that simplified fully. We want to simplify all the way. Okay, number 12, we're going to graph the following function. So this right here, we have intercept form or factored form. So this will already tell us what our x-intercepts are. Okay, so our x-intercepts are going to be positive 3 and negative 1. because if we were to set these equal to 0, the signs would change. Or just taking them out from parentheses, signs change. So I need to look where my graph crosses at 3 and -1. So far A looks good. B looks good, right? -1 and 3. And then C and D, no. Okay, so those have -3 and 1 as their x-intercepts. So clearly forgot to change those signs, and we always change the sign for the x-intercepts. Okay, so what we can do now is figure out what the vertex is. So if you were to look at these, right in the middle is going to be our axis of symmetry at x equals 1. Okay, so in my vertex, I know x equals 1. Another way you can figure out your vertex is the formula p plus q divided by 2. So you would just add together p plus q and divide by 2. That's another way that you can get your value for your vertex, okay? So once you have 1 in your vertex, you're going to plug it in to get the y value. So I'm going to plug in 1 here for x and also here for x. And we have -2 times 2, so y equals -4. So my vertex will be at 1, -4. And if you look at A, it's at 1, +4. Okay, so A can't be our answer. Another reason why A can't be our answer, our A value out in front is a +1. So the graph really should be opening up positive. So our answer is going to be B, where we have a vertex at 1, -4. Number 13, the graph of this equation is shown below. For what value or values of x is y equal to 0? Okay, so there's different ways we can do this. I will go ahead and just look for y equals 0 on the graph. So y equals 0 here. So it's basically asking us, where do I have it crossing y equals 0? Here and here. So this ordered pair is -3, 0 and 2, 0. So the values of x are -3 and 2. So it's really just asking about x-intercepts. So you can keep that in mind. Anytime y equals 0, we're looking at x-intercepts. Number 14, which ordered pair is the vertex? Okay, so this time in standard form, anytime we want to find the vertex, it's the equation x equals -b over 2a. So we're going to use that equation to find the vertex. In this equation, I have a equals -5, b is 20, and c is -9. So I'm going to plug in 20 for -b, so that's -20, because when we plug in, we're going to change the sign, over 2 times -5. So -20 divided by -10 will give us 2. So my x value in my vertex is 2, but then I'm going to plug it in, -5 times 2 squared plus 20 times 2 minus 9, and plugging it in will give me the y value. So order of operations, I'm going to square the 2 first. So -5 times 4. Then I'll copy down the rest. Next step in our order of operations is to multiply. So -5 times 4 is -20. And then 20 times 2 is +40. Copy down -9. Add and subtract left to right. -20 plus 40 is 20, and 20 minus 9 is 11. So we have 2, 11 for our vertex. Number 15, the length of a rectangle is 6 inches longer than the width. Then they tell us that the perimeter of the rectangle is 30 inches. So what is the width? Okay, it's helpful if we draw. We're talking about a rectangle, and all they tell us about the sides is that the length is 6 inches longer than the width. We don't know what the width is, so we can go ahead and just call it x. Okay, so that will represent the width. Then, to label the length, we know the length is 6 inches longer than the width, so I'm going to call the length x plus 6, because whatever the width is, we're going to make it 6 inches longer, or plus 6. Okay, so perimeter means we're going to add up all of the sides and we will set it equal to 30. So since this width is x, then across is x plus 6. So this is x plus 6, and we're going to add all of that, and it's equal to the perimeter, which is 30. So we're going to combine like terms to get 4x. 6 plus 6 is 12, equals 30. Then subtract 12. 4x is equal to 18. Then dividing by 4, we get 18 divided by 4. So 4 goes into 18 4 times. 4 times 4 is 16. 2 is your remainder, but if you see here, they want decimal places. So we're going to put in the decimal and add in a 0. Then move the decimal up, bring down the 0. 20 divided by 4 is 5. So x is equal to 4.5. Okay, they're not saying solve for x. They're saying what is the width. So we want to make sure we read the question. What is the width of the rectangle? Well, we did call the width x. So we are going to be done when we get x. X equals 4.5. Number 16, how many times does the graph intersect the x-axis? So that is really asking how many real solutions. How many real solutions? Okay, so we're not solving it. We're going to use our discriminant, b squared minus 4ac. Okay, so my a is 3, my b is -1, and c is 3. So I'm going to be plugging in these numbers here. So b is -1, so -1 squared minus 4 times 3, because a is 3, times c, also 3, so plug that in for c. Then -1 squared is 1, because -1 times -1 is 1. And then multiply -4 times 3 is -12, and -12 times 3, -36. 1 minus 36 is -35. Because my discriminant is negative, that means I'm going to have no real solutions, or I'm going to have imaginary solutions. So this would mean it does not cross the x-axis because there's no real solutions. 17, we're going to figure out what the solutions are to the equation. So just so you guys know, you would be able to factor this and then set your factors equal to 0, but looking at the answers here, it looks like we're wanting to practice the quadratic formula. So this is a mistake on our part. We're wanting you to practice quadratic formula. We could have picked a better problem, but that's okay. So I'm going to have us practice opposite b plus or minus the square root of b squared minus 4ac all over 2a. So remember, the quadratic formula is the method that you want to choose if it's not factorable. Okay, so, but we are going to just go ahead and practice this. So a equals 5, b equals -1, and c equals -4. I'm going to plug these numbers into that equation. So opposite b means we're going to change the sign for b. If b is -1, when we plug it in, it's +1, plus or minus the square root of -1 squared, because b is -1, minus 4 times 5 times -4, all over 2 times a, so 2 times 5. So x equals 1 plus or minus the square root. Negative 1 squared is 1. Negative 4 times 5 is negative 20. And negative 20 times negative 4 is positive 80 all over 10. And 1 plus or minus square root of 81 all over 10. And at this point, you really could do the square root of 81 and get 9, but just for the purposes of this and understanding quadratic equation, I guess you would divide by 10 to the 1 and also by the square root of 81. And it looks like then our answer would be C. We don't want to mix that up with like D, right? Because the I is whenever you have a negative under the square root. So if this were square root of negative 81, then we would bring out I. But it's positive 81, we don't use I. Number 18, we're going to write the equation of this function. So if you look here, we can already understand that our vertex is going to be 3, 6, and this is all in vertex form. So remember when we are in parentheses with the x value, it's going to change sign. So if this is positive 3, when it's plugged in, it's negative 3. So we can already eliminate the positive 3 for for part B and C. So again, your x value is 3, so plugging it in would be negative 3 for vertex form. So my answer has to be A or D. I will say that just by looking at this looks a little bit wider than your regular x squared parent function. So you know your A value has to be less than 1. So I would pick A. Okay? Because this would be a vertical stretch, which would mean this parabola would be much skinnier, or a lot steeper. So I'm knowing our answer will be A. So the way that we know for sure is using this point right here. So I know that my vertex is 3, 6, and then this is going to be just a point x, y. So I have my vertex form, which is y equals my A value times our x minus h squared plus k, where the vertex is h, k. And then this point, 5, 7, is just an x and a y. So 7 equals the A that I don't know. We're going to find the A value right now. X will be 5 minus 3, right? Because x minus h would be 5 minus 3 squared plus k, which is 6. Okay, so we're going to solve for A and be able to tell you that the A value is 0.25 or if it's 4. So in my parentheses here, I'm going to get 2. Then I have 2 squared, which is 4, so it's actually going to be 4A plus 6. Then subtract 6 to get A by itself, and then divide by 4. So we get that A is 1 over 4, which is the same thing as 0.25. So my answer has to be A. Okay, number 19. Mike is studying the function shown. He claims that he can transform the function to include the ordered pair negative 3, 4. So negative 3, 4 would be here. We're going to select the function that supports his claim. So what would he do to this f of x function to translate it 3 units to the left? So we're trying to translate 3 to the left so that this ordered pair is included. So this right here means translate 3 to the right, because we always change the sign in the parentheses. So this is minus 3, so it actually means positive 3. So this means go 3 to the right. This one is translating 3 units down. This is translating 3 units up. And then here, again in parentheses, change the sign. So this actually means we're going to translate 3 to the left. So my answer is D. Number 20, we're going to look for the expression that represents this. So what happens here is we're subtracting two complex numbers. So the first complex number we're going to leave, but when we're subtracting, think of distributing the negative. So it'll be plus 2 minus I. Okay, so then you combine your real numbers. 5 and 2 gives us 7. And then combine your imaginary. 2I minus I is positive I. So my answer is B, 7 plus I. Number 21, if the parent function is f of x equals x squared, we're going to write an equation g of x with the following transformation and indicate the vertex. So a vertical stretch by a factor of 3. Remember, that means we're going to be multiplying out in front by 3. A reflection in the x-axis means we are going to have our function negative, and then followed by a translation 3 units left. So which one of these three would represent that? So this is just a graph in case you want to use that to do each transformation individually, but we can really just look at these, okay? So if we want a vertical stretch by a factor of 3, we can already eliminate D because that is a vertical shrink by a factor of 1/3, okay? A reflection in the x-axis is a negative out in front. So I already know the answer is going to be C. Again, reflection in the x-axis negative out here for our A value. And then translating 3 to the left is going to affect the inside of the parentheses next to x, and 3 to the left, we remember, actually is plus 3. So my answer is C. Again, this means translating 3 left. The 3 means a vertical stretch by a factor of 3, and that negative is the reflection in the x-axis. And then this is just indicating our vertex is at -3, 0. Again, change the sign for what's inside, and then there's an imaginary plus 0 on the outside to give us -3, 0. Okay, we're going to solve for y. So this is back to Unit 1, where we are going to use our elimination method. So you want to have the same number top and bottom for the coefficient, 1 positive, 1 negative. So I have a positive 6. I'm going to go ahead and multiply the top equation by -6 for that to be able to cancel. So multiplying by -6 to this top equation will give us this. Then copying down the second equation underneath, doesn't change. And now we're going to combine or add down. So the -6 and 6 cancel. 12 and -3 is 9, so we have 9y is equal to 30 plus 6 is 36. So we're going to divide by 9, y equals 4. Okay, so typically we would plug this back in, right, if they wanted us to solve the full system, but they only wanted us to solve for y, so y equals 4. Number 23, we're looking for the value of just the x coordinates in the solution for the systems. So we're going to use the substitution method. Since this y is equal to 2x minus 2 and this y is equal to this, we're going to set them equal because, again, you're just plugging in for y in the other equation. So 2x minus 2 is equal to x squared minus 7x plus 12. Again, they're both equal to y, so they're going to be equal to each other. Okay, I am going to want to solve this. So I'm going to move all of my terms to one side, and I'm going to try the factoring method. So since this is already a positive a value, I'm going to move over the 2x by switching the sign, right? Inverse operation, subtract 2x to both sides, and then add 2 on both sides. And that leaves me with x squared minus 9x plus 14. And then I'm going to factor. So x times x and 7 times 2 to add up to negative 9x. X times 7, if we multiply diagonally, is 7x. And x times 2, multiplying diagonally, is 2x. These would both need to be negative to get to negative 9. So this is negative, this is negative. My factors are x minus 7 and x minus 2. So once we have our factors, we're going to set those factors equal to 0. And I'll show that work over here. X minus 7 equals 0. And x minus 2 equals 0. So solving, and then many of us can do this without showing the work, and that's cool. We get x equals 7 and x equals 2. So it turns out multiple choice, it was a mistake. Here are your solutions. Or not solutions, your x coordinates of your solutions. Okay, for number 24, we're going to look for which statements about this function are true. So, does the parabola open down? No. Okay, because of this being a positive a value, so it's a positive 1 for your a value, means that the parabola will open up. Okay. The x-intercepts of the graph are negative 7 and negative 1, okay? So we don't know just by looking at this. So what we're going to do is remember that x-intercepts also mean solutions. So I'm going to go ahead and solve this by factoring, put it in intercept form or factored form. So we're going to factor this. I'll do that work right here. X times x, and then 7 times 1 to add up to 8x. X times 7 is 7x. X times 1 is 1x. Both need to be positive. Carry over the positive, carry over the positive. My factors are x plus 7 and x plus 1. So if I want to know the solutions or the x-intercepts, I would set them equal to 0. Or again, some of you know, just take out the numbers and change the signs. But just so we're sure, we'll show the steps. So we do get that the x-intercepts are negative 7 and negative 1. Is the y-intercept of the graph 7? Remember, the y-intercept is when x equals 0. So the y-intercept will always, in standard form, be the constant. So yes, the y-intercept is 7. The axis of symmetry of the graph is negative 4. Axis of symmetry, we want to remember, deals with vertex, okay? So if they ask us about axis of symmetry, we're going to need to talk about vertex. So to find the vertex, given standard form, you're going to need the formula x is equal to opposite b or negative b over 2a. So here our a is 1 and our b is 8. So negative 8 over 2 times 1, that's 8 divided by 2, we get 4. Okay, so I know the x value in the vertex is 4, and the axis of symmetry is going to be the x value in the vertex. I guess we can write that in. The x value, right? So that is positive. I'm sorry, I messed up here. Negative 8, right? So negative 8 divided by 2 is negative 4. That's right. So yes, negative 4 is going to be the axis of symmetry. Then they're asking about the minimum value. So is the minimum value 9? Negative 9. So minimum value is now going to talk about the y value in the vertex. So to get that y value, we're going to take negative 4 and plug it back in. Okay, so if I plug in, I get negative 4 squared plus 8 times negative 4 plus 7. So 16 minus 32 plus 7. 16 minus 32 is negative 16, and negative 16 plus 7 is negative 9. So just overall, big picture, that just means our vertex is negative 4, negative 9. So the maximum value should be -9. So what happens here is we want to understand that minimum value is really just the y value in the vertex. I hope this is making sense. It's like getting late on Friday afternoon. Sorry. Okay, so we're looking at the y value in the vertex, and we'll just stop there because I'm just confusing you. Okay, so again, all of this are just all the different characteristics you need to know. X-intercepts is solving, and y-intercept will always be this constant, and then axis of symmetry, minimum value are talking about vertex. So lots of things happening in number 24. Number 25, when y equals 1/3, what is the value of this fraction here? Okay, so what we're going to do is plug in 1/3 for y here and here. So 9 times 1/3 minus 5 divided by 1/3. So 9 times 1/3, we're going to be multiplying 9 times 1/3. So what I did was I put a 1 underneath the 9 to make the whole number a fraction. So multiplying across, 9 times 1 is 9, 1 times 3 is 3, and 9 divided by 3 is 3. So on the top of this, 9 times 1/3 gives us 3. So it's 3 minus 5 divided by 1/3. 3 minus 5 is -2. And then we have -2 divided by 1/3. So anytime we're dividing with fractions, a way you can think of it is multiply by the reciprocal. So keep the -2, and then we're going to multiply by 3/1. So again, dividing by 1/3 really means multiplying by flipping that fraction. So -2 will make a fraction by putting a 1 underneath, and then multiplying across, we end up with -6/1, which gives us -6. Number 26, Keith has $500 in a savings account at the beginning of summer. He wants to have at least $240 by the end of summer. He's withdrawing $25 each week for food, clothes, and movie tickets. How many weeks can Keith withdraw money from his account? Okay, so this is going to be setting up like an inequality, okay? Sort of think of it that way. So he has $500 in his savings account, and he is withdrawing money. So he's subtracting 25 each week, okay? So withdrawing 25 each week from the savings. And he wants to have at least $240 by the end of summer. So whatever he has over here cannot be less than $240. You can think of it that way. Okay, so how many weeks can he withdraw money from his account? So we can go ahead and just think of this as an equal sign, but think about we don't want to be anything below $240, okay? So to solve for x, we would subtract 500. -25x is equal to 500 minus 240. That's -260. So then we would divide 260 by 25 to get 10.4, right? If I divide both sides, maybe I should show that step, by -25, then x equals 10.4. Okay, so maybe, yeah, I'll show the work for that. 260 divided by 25. 25 goes into 26 one time. 1 times 25, and then bring down. And 10 divided by 25, okay, goes in 0 times. So then we have this 0 times 25, 0, and then we're going to bring down 100 divided by 25 is going to go in 4 times. So we end up with 10.4. Okay, so this means he's going to get to $240 in 10.4 weeks, okay? So we don't want to round up, because if we round up, then we're going to exceed $240. And remember, he wants to have at least, so we can't exceed, we don't want to get anything smaller than 240. So we have to pick 10. We want to round down, okay? Because rounding up would go and take too much money out of his account, and then the number would be less than 240. We want to stay greater than 240, so B. Number 27, a line is drawn through the origin and 6, 9 is shown passing through our line through that point. The acute angle between the line and the positive x-axis have a measure of theta. So basically the line with the x-axis is going to form this angle. I'm going to make that bigger. There's theta. And then they want to know the value of tangent theta. So if you look at your ordered pair 6, 9, we can find tangent if you think about this as a right triangle, okay? Because of the ordered pair 6, 9, that means we are 6 on the x-axis and then 9 on the y. So that's going to label 2 of our sides in the triangle. This is our opposite from theta and our adjacent to theta. If they want us to find tangent, remember tangent means opposite over adjacent. Opposite of theta would be 9, and adjacent would be 6. And that simplifies when we divide out 3 top and bottom, and we end up with tangent of theta being 3 over 2. Number 28, if 2x plus 13 is 5 more than negative 10, what is the value of 3x? Okay, so don't let this thing confuse you. This just means there's going to be a second step. Okay, so we're going to find x first. After we find x, we're going to plug it in right here and multiply by 3. So we're going to use this first part to create an equation. 2x plus 13 means equals 5 more than negative 10, just means add 5 to negative 10. Okay, so we're going to solve for x. So combining like terms and then moving over the constant gives us 2x equals negative 18. Dividing by 2, x is equal to negative 9. But we're not done, so don't pick A. They want to know the value of 3x. So what we'll do is take the x and plug it in up here. So 3 times negative 9 gives us negative 27 as our answer. Number 29, which of the following is an equivalent form of the equation of the graph shown in the xy plane, from which the coordinates of vertex A can be identified as constants in the equation? Okay, so what we want to keep in mind is that they're asking us for vertex form. We want to think about vertex form. So go ahead and eliminate this intercept form. Okay, we know we're crossing the intercepts at 1 and 3, so this would actually be a correct way to write the equation for this parabola, but this would be in intercept form and we want vertex form. So we're going to eliminate both of these. Okay, so we want vertex form. Looking at this parabola here, our vertex is at 2, 1. So remember when we write in vertex form, the x value goes in parentheses and it changes signs. So we are choosing C as our answer. Again, change the sign for that x value. We have negative a values, by the way, because this is a negative, the upside down or parabola here. Okay, number 30. In the figure below, both lines P and Q are parallel and M and N are parallel. If the measure of angle 1 is 155 degrees, I'm going to go ahead and write that in. What is the measure of angle 2? So given this, I need to find this angle measure over here. So just before we start, understand there's so many different ways you can do this, applying our different rules, but just this way I think might be the easiest. Okay, so because this is 155 degrees, by corresponding angles, then this right here is going to be 155 degrees, okay? This is already going to be a relationship in our parallel lines with the transversal. These are called same side interior, and these are going to be supplementary. So we can go ahead and solve it that way. So I don't know what angle 2 is. I'll put x, and I'm going to add that with the 155 to equal 180. Again, because these are same side interior, so same side interior angles are supplementary. They add up to 180. So to solve for x, I would subtract 155. So x is equal to 25 degrees. The measure of angle 2 then is 25 degrees. Number 31, the equation f of x is equal to x minus 1 squared minus 4. For representing f of x, and then the graph below is for g of x. So what we are going to go ahead and do before answering this is do a quick sketch of this. Vertex form, I know my vertex is at positive 1, negative 4 again because we always change the sign here. So at 1, negative 4, I'm going to put the vertex, and then because of this being a positive 1, positive a value, this graph will open up, and I'm going to label it f of x. Okay, so is the line of symmetry for g of x equal x equals negative 4? Yes, this line of symmetry for g of x is at x equals 4, so that is true. Remember, line of symmetry is looking at the vertex, right? The minimum of g of x, so here's my minimum for g of x, is less than the minimum of f of x. That's false, because if you look at the minimum here, it is a little bit greater than the minimum here because we're looking at like their x values. How high up are they on the graph for the minimums, okay? So this one is greater, not less, so false. The value of x when f of x is at its maximum is less than the value of x when g of x is at its maximum. So what we can do is write down the ordered pairs to maybe make it a little bit more visual. These are each of the vertex here, okay? So the value of x when f of x is at its maximum is 1, right? Is less than the value of x when g of x is at its maximum. Is that true? Is 1 less than 4? Yes. Number 32, we're going to solve the quadratic equation by finding the square root. So what that means is we're going to be doing all of our inverse operations to get x by itself. So first thing we'll do is subtract 6. So 3x squared is equal to 54. Then divide by 3, and x squared is going to equal to 18. Our next step would be to do the square root. So we're going to do the square root to both sides. Whenever we're solving equations, with a square root, it's always plus or minus. Okay, I don't want to leave my answer like this because that square root 18 can be simplified. So whenever you're trying to simplify square roots, you want to think of your list of perfect squares like 4, 9, 16, 25, 36. Okay, so can you divide out a 4 from 18? No, but you can divide out a 9. So I'm going to rewrite this as x equals plus or minus square root 9 times the square root of 2 to give you square root of 18. We can do the square root of 9. The square root of 9 is 3. Square root of 2 can't be simplified, so you just leave it. And we have x is equal to plus or minus 3 square root 2. We're going to solve the following equation by factoring. So remember, factoring method, we're going to factor and set our factors equal to 0. So 3x times x, and then think of numbers that will multiply to 6. We're going to try to add up to negative 7x. So we can try 3 times 2, or 2 times 3, 6 and 1, or 1 and 6. Looks like 2 times 3 would be a good pick. So multiplying diagonally, x times 2 would give us 2x, and 3x times 3 is 9x. These would need to be different signs to get to negative 7. We keep the sign from the larger number, so larger number should be negative. Positive on the top, negative on the bottom, and our factors are 3x plus 2 and x minus 3. So our procedure is to set this equal to 0 and the second factor equal to 0. So to show that work, 3x is equal to negative 2, divide by 3, and x is equal to negative 2/3 for our first solution, and then x equals 3 for our second solution. So negative 2/3 is a real part of this. So we want to know that when we have the parentheses here next to each other, we're going to be multiplying. So 9 times 5 is 45. 9 times negative 6i is negative 54i squared. Sorry, negative 54i. 2i times 5 is 10i. And then 2i times negative 6i is negative 12i squared. So we have to remember that I squared is equal to negative 1. So simplifying here, negative 54 and 10 is negative 44i. And then negative 12, I'm going to be multiplying by negative 1 because I squared is equal to negative 1. Okay, so negative 12 times negative 1 is positive 12, and they want the real part only, so adding 45 and 12 will give us the real part of our complex number. So my answer is 57. Number 35, we're going to solve the following quadratic by finding the square root. So we're going to be moving everything away from x using our inverse operations. First step will be subtracting 3. So 2 times x minus 1 squared is equal to 54. Then we're going to divide by 2 on both sides. Remember, you never distribute into parentheses squared. So x minus 1 squared is equal to 27. Then square root both sides. X minus 1 is equal to plus or minus, and we can't do the square root of 27, so I'm going to leave it there under the square root. But again, you always think about our list of perfect squares, 4, 9, 16, 25, and if we can divide out one of these numbers from here so that we can simplify. So can we divide out a 4 from 27? No. Can we divide out a 9? Yes. So I'm going to rewrite the square root of 27 as square root 9 times square root 3. So then the square root of 9 simplifies to give us 3. And then square root 3 stays because that can't be simplified. Last step is to move the 1 over to the other side to get x by itself. So x is equal to 1 plus or minus 3 square root 3. You do not combine the 1 with this part here, you just leave it out in front. Number 36, graph the following equation. So this is in standard form. The first thing we're going to need to do is find the vertex. So again, using our formula, x equals negative b over 2a, or opposite b over 2a. My a is 2, b is 8, and c is 9. So opposite b would be negative 8 over 2 times 2 times a. So negative 8 divided by 4 is negative 2. So I know the x value in my vertex is negative 2. To find the y value, we're going to plug in negative 2 back to the equation. So 2 times negative 2 squared plus 8 times negative 2 plus 9. Order of operations, we're going to square the negative 2 first. Negative 2 squared is 4. Then I'm just going to copy down the rest. 2 times 4 is 8. 8 times negative 2 is negative 16. Copy down plus 9. 8 minus 16 is negative 8. And negative 8 plus 9 is 1. So negative 2, comma 1 is my vertex. Okay, we can talk about minimum or maximum after we make the graph, just so that we don't get mixed up. So we'll answer those after. Okay, when I'm graphing, it's important to make a table so that I get 5 points for a nice and precise, accurate graph. So I'm going to put the vertex in the middle of the table, negative 2, 1. I'm going to subtract 1, add 1, and add 1 to complete the table. So I'm going to pick 2 points, either the top 2 x values or the bottom 2 to plug in. I'm going to plug in these 2. So when I plug in negative 1 to my equation up here, I will be able to find the y value. So 2 times negative 1 squared plus 8 times negative 1 plus 9. Order of operations, negative 1 squared is 1. So I'll write that down, copy down the rest. 2 times 1 is 2. 8 times negative 1 is negative 8. Copy down the 9. 2 minus 8 is negative 6, and negative 6 plus 9 is 3. Whoops. So when I plugged in negative 1, my y value was 3. So now I have another ordered pair, negative 1, comma 3. Now I'm going to plug in 0. So if I were to plug in 0, some of you remember the shortcut, cancels, cancels, and my answer is 9, but I'll just go ahead and show you. If you were to plug in 0, 0 squared is 0, and 0 times 2 is 0. 8 times 0 is 0, plus 9, we end up with 9. So there's another ordered pair on our graph. And then remember, this is our vertex where our line of symmetry is. So whatever y value is 1 to the right will be the same as what's 1 to the left. And whatever is 2 to the right is the same as what's 2 to the left. So to graph these, negative 4, 9, negative 3, 3. We already have the vertex here at negative 1, 1, negative 1, 3, and then 0, 9. And that would be my accurate graph. This vertex has a minimum. Anytime the parabola is opening up positive, it will have a minimum value, okay? There is no maximum because of these arrows showing that this has infinite answers that go up, right? So we have a minimum, and this parabola opens up. Number 37, we're going to solve by completing the square. Remember, completing the square, b divided by 2 squared is used. Okay, so for completing the square, the first thing we're going to do is move over the constant. So we're going to subtract 24 to both sides, and x squared plus 4x is equal to negative 24. Now what we're doing is we're going to add a number to both sides to to complete the square to create a perfect square trinomial. And whatever we add to one side of the equation, we have to add to the other side. To figure out what that number is, you're using your formula, b divided by 2 squared. Your b is 4, so for b divided by 2 squared, that formula, it's 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4, so adding 4 to both sides. Now we have our square trinomial. We can factor this and make a square binomial. So if I were to factor this, it would be x times x and 2 times 2. Your factors would be x plus 2, x plus 2, or x plus 2 squared. So if you want to take the long route, you could factor that and come up with x plus 2, which is x plus 2 squared, or using the shortcut, b divided by 2. So your b value divided by 2 will always be this, what's inside your square binomial. And that's equal to negative 24 plus 4, which is negative 20. Now to solve, I'm going to get rid of the parentheses because I'm trying to get x by itself. So getting rid of parentheses squared, I'm going to do the square root to both sides. That leaves me with x plus 2 because the parentheses squared will cancel out with the square root. And so left with x plus 2 equals plus or minus. It's always plus or minus when you're solving when you have to do the square root. Negative means imaginary, so I'm going to take out I, and then I'm going to leave square root 20 inside the square root. But we can simplify because, again, think of your list perfect squares, 4, 9, 16, 25. These are the numbers we can try to divide out. So x plus 2 is equal to plus or minus I, and then we're going to rewrite square root 20 as 4 times 5. Okay, so from here, I should have wrote smaller, sorry guys. X plus 2 is equal to plus or minus 2, or I times, right here, square root of 4 is 2. And then we're going to leave square root of 5 alone. So this is going to become, if we plus or minus 2i square root 5, okay? And then our final step is going to be to get x by itself by subtracting 2. And x is equal to negative 2 plus or minus 2i square root 5. So we had to do quite a bit of simplifying there with that square root of negative 20. Again, negative you bring out and it's I. And then broke this down as 4 times square root 5. The square root of 4 is 2. And we rewrite this as 2i. Square root of 5 stays. And then we just move the 2 to the other side by subtracting 2. And there's your solution, completing the square method. All right, last question. Oh man, it's 5 o'clock on Friday afternoon, you guys. I'm sorry if hopefully I'm making sense. Okay, so we're gonna write this equation in vertex form. When it's in vertex form, remember we're looking for the parentheses squared. So we are going to be completing the square when we write in vertex form. We're going to be completing the square. Okay, so what I'm going to do first for completing the square is I'm going to get rid of the y for a second, and I'm going to set this equal to 0. Then I'm going to move the constant over, so I'm going to move the 1 to the other side by subtracting 1. So 3x squared minus 6x is equal to negative 1. I don't want to add a number to both sides to complete the square yet. Because I have an a value other than 1, I need to divide that out first. So I'm going to divide out the a value, divide out 3 from both of these terms, and it'll leave me with 3 times x squared, right? So x squared inside parentheses, and then minus 2x. So I'm, again, looking for the square binomial, so I'm going to need to complete the square for my trinomial on the inside of the parentheses, and we're also then going to be adding a number to the other side. To figure out what number to use to add for completing the square, we will use the formula again, b divided by 2 squared. But this time, our b is negative 2. So negative 2 divided by 2 squared. Negative 1 squared is 1. So we're adding 1 here. But be careful, because of the 3 on the outside of parentheses, distributing or multiplying 3 times 1, we're actually adding 3. So make sure you multiply whatever is on the outside of parentheses 3 times 1 to give you the 3. Okay, so 3 stays. Now we're going to rewrite this trinomial as a square binomial by factoring. If you were to factor this, it would be x minus 1 and x minus 1, which is giving us x minus 1 squared. Or the shortcut is b divided by 2. If you just divide this b by 2, you get negative 1. That's equal to negative 1 plus 3, which is 2. Vertex form, we're not going to solve. All we're going to do is move that 2 back to the other side of the equal sign. So to do that, subtract 2 to both sides. And I end up with y equals 3 times quantity x minus 1 squared minus 2. Okay, so again, moving positive 2 back over makes it negative 2, and that is the equation in vertex form. All right, guys, make sure you study.